Okay, so if we consider our log graphs, in particular logs of base E, okay, so we've got our standard log graphs here. You can see our log base 2 graph here, and just the general shape, they all have that shape. It doesn't matter which base it is. It's a bit like our exponential graph, whether it's 2 to the power of x or 3 to the power of x, they've all got the same shape. Log base 10 has got the same basic shape. They all go through the point 1, 0. All right. Log base E, we give that a particular name. That's called our natural log. Okay. And if you remember from last year, E is simply a number, 2.71, blah, 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 blah. Okay. So it's just a log base that acts a little bit between log base 2 and log base 3. All right. They all have the same key features though. Those key features all cross the x-axis at 1, 0. All right. A vertical asymptote, which means the domain is R plus. The range is R. These graphs continue up and down. Okay. They're all increasing functions. The smaller the value of A gets, the more rapidly it increases. In other words, log base 2 is steeper than log base 2.7 or E, which is steeper than log base 10. All right. Our manipulation of them, though, the graph of them, are identical. All right. So if we've got our axes over, oh, that's a bad line. If we've got our axes over here, so we've got our axes over here, we know that the standard graph, I'll just do a standard graph here. There's log base anything. So we've got log base E. So the other thing I probably should have emphasized is log base E can also be written as natural log of X. Okay, ln of X. So the same thing. Our CAS tends to use that sometimes. I tend to write that way simply because it's one letter less. Okay, so there's my standard graph. What's happening to my standard graph? Well, let's have a look. 3 units, so we're going to go 3 units to the right, 1 unit up, and we increase. So we're going to dilate by a factor of 2. Y value gets bigger from the x-axis. All right, so let's put the things into place that we have to. We're going to shift 3 units to the right. So there's my vertical asymptote at x equal to 3. That point there, which is normally at 1, is moved 3 units to the right, which would be there. Yeah. The only thing is now the whole graph's moved up 1 unit. So my graph is going to look a little bit like that. Okay. We need to find an intercept. Okay. So I've just read the question, boys, and it seems we don't have to sketch it, but it's good practice to sketch the graph. We just need to state the transformations. So we sort of identified the transformations. So my transformations formally, well, we've already said multiplied by a factor of 2 from the x-axis. 1 unit positive y direction. And we can have 3 units positive x direction. So it certainly pays to read the question, doesn't it? All right. Question 2, or example 9, says sketch the graph. Hey, now we're all cooking. So if I ever go at sketching this graph, whoop, maybe over here. So let's identify my transformation still. To the left 1 unit, down 2 units. Okay, so my asymptote is moved to the left. What did I say? Left 1 unit. So x equals -1. The whole graph has moved down. So my intercept normally goes through 0. Sorry, through 1. It would normally go through there, but the whole thing's moved down 2 units. So more than likely, my graph looks a bit like this. Okay, let's find x and y intercepts. So I'll put the y-intercept first because that's typically easier. Put x equal to 0, and we get y equals natural log of 1 minus 2. Natural log of 1 is 0, so I get the point 0, negative 2, which seems reasonable. To get my x-intercept, let's put y equal to 0. So I get 0 is equal to the natural log of x plus 1 minus 2. Take the 2 across. Now remember our change of base rule. The base is e, so that means e to the 2 is equal to x plus 1. So that means x is equal to e to the 2 minus 1. All right. So we'll go over that process probably a little bit more next exercise, but we hopefully remember that from last year. Otherwise, of course, we could use our CAS. All right, so there's my e to the 2 minus 1. All right, so let's have a quick check. Mark vertical asymptotes and intercepts. We've done that. All right, move on. Here's another sketch the graph. Sketch the graph of f of x equals to that. I need asymptotes, intercepts. I've got to state the domain and range this time, and I can use my CAS. All right. So let's get a graph over here somewhere. And I think one of the first things we should do is let's rewrite our function. F of x equals negative 3 natural log. Now if I put that negative sign out the front there, I get a positive x. That's a plus 1, so it should be a minus 1 in there. And then I've got plus 2. So I do that to help me identify what the series of transformations are. Negative sign out the front. So let's actually list them. Negative sign out the front is reflect about the x-axis, isn't it? Turns it upside down. Let's keep with the 3. The 3, it's a dilation by factor 3. So it stretches the y, so it's from the x-axis. That negative sign in there reflects about the y-axis. About the y-axis. The 1 here, 1 unit, positive x direction, and we'll go plus 2, 2 units, positive y direction. Now I know I didn't ask us to do that, but I think that's really good practice. All right, what do we know? What do we know? Probably not much. X minus 1 can't be 0 because that's where my asymptote is, so I know it's moved 1 unit to the right. So let's put our asymptote in at x equal to 1. Now with my reflections, original graph goes that way. Reflection 1 flips it upside down, so it might go that way. And then reflection 2 brings it back around in the other direction. So I reckon this one here is the graph shape. So what we need to decide is whereabouts it goes through on my x and y axes. So the easiest way to do that is find an x-intercept or a y-intercept. Let's try about that jump. So let's find y-intercept normally earlier, easiest. Y-intercept, put x equal to 0. So we get y equals negative 3 natural log. We're going to the original function, negative 3 natural log 1 minus 0 plus 2. Natural log of 1 is 0, so I just end up with y is equal to 2. So an asymptote there at 2, which means I should have a negative x-intercept here somewhere. So let's find that negative x-intercept. So let's put 0 is equal to negative 3 natural log of 1 minus x plus 2. So let's take that whole negative log across. So I get 3 natural log 1 minus x equals 2. Natural log of 1 minus x equals 2 on 3. Remember, log base e to the 2 on 3 equals 1 minus x. So x equals 1 minus e to the 2 on 3. So it's probably hard to tell if that's going to be a positive or negative value. So 1 subtracts, so is e to the 2/3 greater than or less than 1? Well, let's have a think about that. We know the graph of e to the x is like that. And if e to the 0 is equal to 1, well then e to the 2/3 is going to be slightly bigger than 1, isn't it? So 1 minus a number bigger than 1 is negative, so that seems fair enough. So there's my graph here, coming up through there, and it's going like that. So let's quick check, sketch the graph of f of x. We've done that, marking asymptote and intercepts. So I better write an intercept down here. 1 minus e to the 2/3. Check, state the domain and range. So let's go in here somewhere. What's my domain? Well, it's all the values less than 1, isn't it? Minus infinity to 1, round bracket, because it can't be 1. Range is equal to r, isn't it? Could be any value along that y-axis. All right, so here we go.